Hello, I have here a uniform rectangular block. Height is 4 cm, the breadth is 2 cm, and the weight is 10 newtons. If we apply a horizontal force at the 3 cm level, how strong must this force be before the block topples? To counter the rightward horizontal force, there must be a leftward frictional force acting on the block. In fact, the magnitude of this frictional force must be exactly equals to F. To support the weight of the block, there has got to be a 10 Newton normal contact force acting on the block as well. If we take moments about the CG of the block, then we have the clockwise moments created by this couple. So F times 3 cm being balanced by the anti-clockwise moments produced by this 10 Newton force here. So 10 Newtons multiplied by, let's call this x, the distance between the line of action of the 10 newtons and the CG of the block. So you see why the line of action of the normal contact force has to be to the right of the CG, because we need that force to provide an anti-clockwise moment to balance the clockwise moments produced by this pushing force and the frictional force. In fact, as we increase F, the pushing force, the line of action of the normal contact force will shift further and further to the right. The largest possible anti-clockwise moments that the 10 Newton force can produce is 10 times 1 cm. Actually, that's when the normal contact force has already reached the end of the block here. If we increase the horizontal force further, then we are going to have a net clockwise moment, and that's when the block will topple. So I know how most students solve this problem is to immediately take moments about the right edge of the block here, this point here. So when you take moments about this point, then the normal contact force and the frictional force exerts 0 moment. So all you have is the clockwise moments by F, so F times 3 is balanced by the anti-clockwise moments produced by the 10 Newton force, so 10 times 1. So you have solved that the block will topple when the horizontal force reaches 3.33 newtons. So getting this answer is not difficult, but I hope you appreciate how the normal contact force line of action actually shifts further and further to the right until it cannot shift anymore, and that's when the block must topple. Okay, that's all. Ta-ta!